This is a talk about JUnit 5, and I want to talk about, some of the features I really like about it. You know, a lot of the good things I find very particularly useful, especially in the last few versions of JUnit 5. They've added some nice things to it, and I want to illustrate that. Now, just for your information, my name is Kousen. It's cousin like the relative. It just doesn't look like it. We think it's an Ellis Island job or something. Who knows? There's my email address, homepage, blog. I still have a Twitter account, although I try to avoid the place if I can. I have a Mastodon account as well, and every Sunday I put out a free weekly newsletter called Tales from the Jar Side, which is on Substack. And every Monday I put out a video version on my YouTube channel and some other technical videos, including several on JUnit testing as well. The books that I've written in the past are all listed over on the right, but you don't need any of that for this. But they all have JUnit tests in them, including the Kotlin book and the Groovy book, all of that. That QR code, by the way, goes to the YouTube channel, just so you know. So you don't have to go check it out to find out what it is. There's that. Okay, let's talk about JUnit. Now, JUnit is probably one of the most well-known and frequently used APIs in the entire Java ecosystem, and it's been at JUnit.org forever. These days, if you go there, I magnified a lot here, but it redirects to JUnit.org/JUnit5, so it's on the latest version right here. There's still a link to the legacy stuff. One of the features that I want to mention right off the bat, so that I don't forget, one of the nice features about JUnit 5 is that you can still run all your legacy JUnit 4 tests with it. Even, believe it or not, JUnit 3 tests, if you really want to. Tests that used to have test cases as superclass if you were in JUnit back then. All that stuff still works. You just need to load what they call the vintage engine. It's just another dependency for your project. And if you load that engine, then what this means is, from a practical point of view, you don't have to migrate all your existing tests to JUnit 5 right away. You can just say, I'm switching the dependency to JUnit 5 plus the vintage engine, run all your old tests, and then just start making new ones in JUnit 5 if you like. So the migration path is as simple, as gentle, as easy as they were able to make it. Okay, the upgrade to JUnit 5, rewriting something that everybody used for years, was a big deal, but they paid attention to the needs of the community, and they were very good about it. I'm really very pleased with it. Okay, from that home page, you'll see that there's links to a reference manual, which is by far your best source of information on JUnit 5. I mean, it's very, very good. Plus, they have their Java docs, which of course they refer to as API docs as well there too. So that's good stuff as well. And if you go to the GitHub repository, I don't go there because I want to see the code for JUnit 5, although that's valuable. They have in the parent project, let me just give you an idea here. So if this code in issues 1 goes to GitHub. So if I open that in a tab here, and you see that I'm at the JUnit 5 project under JUnit team. And if I go to JUnit team, underneath is a project called JUnit 5 samples. And this always has the latest starter code for any of the build tools that you might want to use. So you see, I left it a little smaller just so I could fit it on the screen there, but there's a starter project for Basel or for Gradle using the Groovy or the Kotlin DSLs or Maven or SBT, pretty much anything. So they update this with every release of JUnit. You could go in there and see what's the current thinking on what the build file should look like to bring in the dependency. So if I go to Gradle with the Kotlin DSL, for example, here's a build.gradle.kts. Now let me magnify a bit. And you can see here, they use the platform method in Gradle, which is how you load a BOM, a bill of materials in Gradle. So that specifies the current version, and then this is what they call the aggregate dependency. It's both the API and an engine. So in other words, it's what you need at compile time and what you need at runtime. If you look at some older JUnit projects, they'll separate those, and that's fine, but it's not necessary anymore. They put in the aggregate, so you can just add that one dependency and you're good. Now, for some reason, you're going to start getting warnings unless you put in this JUnit platform launcher too. I'm not sure why they're doing this. It will still run without it, you know, but they'll start giving you warnings, and this is exactly what it looks like. This is totally optional, except in Gradle, you have to invoke that plugin method, use JUnit platform, or Gradle will not see your JUnit 5 tests. It'll say no tests found, even though they're there. So you have to remember to call that. But again, it's right in the build file here, and we don't actually need any of the other stuff in here. So this is your source to find out, you know, how you want to get started with this thing if you've never used it before. They even have one for Ant, believe it or not, after all these years. So that's one thing to point out. And it's all, you know, right off the GitHub repository there. Now, I put in a whole bunch of links here, but most of these are the links right off the home page of JUnit. So there's the user guide that I was telling you about. There's a link to the Java docs. They say API, but again, it's just what we call the Java docs. There's the link to the GitHub repository. There's their documentation link is actually a link to Stack Overflow with the tag JUnit 5, which that's getting to be pretty dated, isn't it? I mean, what are AI tools going to do to that? But we'll see. However, one link that is not on that home page that you may want to know about is that the JUnit team maintains a Gitter group. I don't know if you've ever used Gitter before, but Gitter's like an online Slack channel. Really is. It's just not Slack. And the team actually pays attention to messages in that group. So that's kind of a useful thing to know about. I have asked questions and not gotten answers, but I've also asked questions and gotten really good answers. It's a source, you know, as much as anything. And then the last link on there is the link to my personal GitHub repository, which is going to be the source of all the examples I'm going to show you today. Okay, so if you're interested, and if I make any changes to that as the presentation goes on, I'll just push the changes to the repo. You can just do another pull and you'll have the up-to-date information there. I use that for a training course on JUnit, so there's a lot of stuff in there, tons of examples that we won't have time for, but I'm going to grab some selected ones just to show you how they work as we go along. Again, if you need to get a hold of me after this is over, you got my email address. It was back here on the front. You know, feel free to send me an email or whatever, or contact me online. My delete key works as well as anybody. No, I shouldn't say that. Okay, moving on. Okay, one thing, by the way, I mentioned that vintage engine. JUnit 5 is actually made up of 3 parts, the so-called platform and JUnit Jupyter and the vintage engine. The vintage engine is one of the 2 real engines you use. One runs JUnit 5 tests, and the vintage one runs the JUnit 4 and 3 tests. You don't have to add the vintage engine as a dependency unless you want to. The platform and the Jupyter distinction is really not important unless you are working on JUnit itself. If you were writing code for JUnit, then it would matter, but otherwise it doesn't matter. Why pick the word Jupyter? Well, there's a couple of really good reasons. One is it gives you an excuse to put up a picture from the Juno satellite going around Jupiter right now. I think yesterday or today they hit Perigove 60 or something, one of the close approaches to Jupiter. So if you're not aware of that, go check out the satellite photos at NASA on their Juno satellite. But the really silly reasons they picked the name Jupyter, one is Jupiter starts with JU, just like JUnit. And Jupiter is also the 5th planet from the sun, so there's JUnit 5, making you wonder, or making me wonder anyway, if they go to JUnit 6, are they going to go to Saturn on this? I have no idea. You know. But again, just a picture, an opportunity to show a pretty picture. Okay, now one thing you do have to be aware of with JUnit is they changed the annotations for the life cycle, and they changed the ability to modify the life cycle. So we used to have before and after, or at before and at after, and at before class and at after class. Now it's just renamed to before and after each for each test, and before all and after all for the overall once per test class. What's new, however, is that now you could change the life cycle itself. And if I go to my GitHub repository, oops, let me grab that here. And I have in here a class called Lifecycle Tests. And let me just verify again. How's the font size on that? You okay with it? Okay, so this is a lifecycle test. I put in a constructor. There's a before all, a before each. I have 1, 2, 3 tests, an after each and an after all. And if I run the whole thing, so let me put my cursor in the class but outside of any method, then you will see before all happens even before you have an object. So in JUnit 5, that has to be static. Okay, that method has to be static because there's no instance before that. And just for symmetry, I assume after all has to be static as well. Okay, then you get the class instantiated, and then before each, and then the test, and then after each as a unit. So before each, the test, and after each are a unit. And as a reminder, and this was normal JUnit 4 behavior, the class is reinstantiated between each test. Okay, that's the default behavior. One of the neat things in JUnit 5 is that now we have a test instance annotation that allows you to change that. Right now, we're making a new instance of the test class between each test, but we can actually switch that to per class, and now we'll get one instance for the entire class, and the constructor happens even before the for all, so now you're allowed to make the before all method an instance method. Doesn't have to be static anymore. But you only get one instance no matter how many tests you run, and then the after all at the end. So this is something that people wanted that you can now do. You can actually pick. The default, again, is before class, which was the default in JUnit 4 as well, but it was hard to change that in JUnit 4. Now it's easy to change it. Okay. One of the neat things that people don't use that often, and I think is pretty fun, is that now you have an annotation that lets you put in whatever test name you want. Now, mostly you use it so that the test name has got spaces in it and apostrophes and something readable, but you can do this. I took these directly from the user manual. You could put in the guy flipping the table if you want. You could put in the monk scream emoji if you want. I mean, they all work, and it just depends on you having the proper font on your console, you know, or whatever page you're rendering with the output results. What I use it for is, again, to make it so that, you know, when you start chaining together a bunch of words in camel case, they become difficult to read. Now you can put in something readable, and they actually have several display name generators built right into the API. This is one I use a lot, display name generator dot replace underscores. The idea is you write in your test name with underscores. This will turn it into spaces on the output report. So much easier to read that way. So you don't have to put one in at all. So this is optional, but that is available if you feel like you want to try it out. And it's a one-liner. You just put it on your class. Now, I should say, this is actually a typical thing in JUnit 5. They have an annotation you could put on each class if you want, but they also have a property you could put in your JUnit properties file that'll do it throughout the entire project. So that's very typical in JUnit 5. They'll either have something local, which is a simple annotation, or something global, quote, which will be in the properties file that we'll look at a little bit later. Okay? Okay, assertions are all the ones you're expecting. Assert true and false, all the overloads of assert equals, assert null and not null, assert same and not same, and of course fail, which was really funny during the Wayne's World times. I thought that was pretty good. That's getting to be a dated reference. I'm not going to dwell on it. So those, of course, behave the way you want, but what's different about these is your supplied error message used to come first in JUnit 4. Now it goes last. So you put in your expected value, the actual test, and then a message at the end if you want to. But here are some of the, and I'm going to come back to that because we'll get to that in a minute. Here's a few of the newer assertions that are available in JUnit 5. And the one it turns out I use constantly is assert all. One of the problems with JUnit 4 is that if you had multiple assertions in an individual test, the first one that fails aborts the test, so that none of the other assertions run. And it's always a classic problem that you have to, split up your test. Well, if I'm making a call to a RESTful web service and getting back a value and making an object out of it, I want to check all the properties of the object. I don't want to have 10 different tests making 10 different calls just because I can only test one property at a time. With assert all of the assertions inside it run successfully or not, no matter how many of which fail. Okay, so if you had 10 assertions in there, they will all run whether they pass or fail. And I have an example of that. So let me bring up my assertions tests here, for example. So like this one is saying, I'm creating a POJO called a book, but assume I got that from a RESTful web service or something like that. Then I can do an assert all, and I could do all my individual assertions in here, and they will all run even if they all fail. So that's really convenient. Now, the thing you'll notice about this is that the argument to assert all is actually a lambda expression. It's not just the individual assertions. This construct here is in fact what they call an executable. Let me see, wait a minute, 1 second here. Should have done this ahead of time. Adjust the font size. Better? See that a little bit better? So this is assert true, but if you look at assert all, it says this takes as an argument executable, ... Now, there's a list of executable, there's a collection, not just a list, a stream of executable. They have a bunch of overloads, but this is the vararg list of executable. What's an executable? An executable is a functional interface that's basically a runnable that throws an exception. See, you know, if you played with streams for any time these days, of course, that streams and exceptions don't play nicely together, right? It's really annoying putting try-catch blocks in the middle of a pipeline. Well, with executable, the exception is declared in the signature, so if it's thrown, it's not your problem. JUnit will catch it. That's the whole point. See, runnable doesn't throw exception. Executable not only throws exception, it throws throwable, in fact, which is an interesting decision, but so be it. But that means anything can happen with this exception-wise, and JUnit will report on it. And they use executable all over the place. Now, I happen to use the overload here to put in a header as well. But these are all executables. They all are lambda expressions that take no arguments and return void, which is what a runnable is, right? So there's runnables that might throw an exception. That's the idea. Okay. Assert throws is now the new way to handle exceptions when something is, you're expecting an exception. In JUnit 4, the assert, or the test annotation had an argument of type, it said expected equals, and you put in your exception there. The problem is anything in the test could throw that exception and the test would pass, not necessarily the thing you were trying. Like if you were trying to catch or expecting a null pointer exception, you could wind up throwing a null pointer exception for an unrelated reason and the test would pass anyway. Now with assert throws, you actually put in the block, the executable again, that's supposed to throw that exception, and the test only passes if you do it. And it works polymorphically, if you will. In other words, you could check for a parent exception, but if you want to check for precisely the exception you're looking for, there's assert throws exactly as well. So over here, if I scroll down a bit, here is an assert throws that will throw some child class of exception. In fact, this was throwing an illegal argument exception. But I could say, oh yeah, assert throws exactly and get that as well. That's relatively new. Well, it says 1.0, so, oh no, I'm sorry, I looked at the wrong one. Yeah, 5.8, which is not that long ago. That's just a year or so ago. So that's pretty good. Okay. Now, assert does not throw is basically just documentation. What you're saying there, because after all, if you're not expecting an exception and one happens, the test fails, okay? So when you say assert does not throw, you're basically saying you might have expected an exception out of this, but it doesn't happen. No exceptions are thrown here. And in looking for a use case for that, what I've come up with is that arithmetic exception. See, if you divide 1 by 0, then you'll get an arithmetic exception divide by 0. But if you divide 1.0 by 0.0, then according to the IEEE 754 spec, actually, you don't get an exception, you get infinity. And then you can multiply by it and get infinity or divide by it and get 0, happily corrupting your data as you go along. you know? And this is according to the spec. This is the way programming languages are supposed to work. So in this one, yeah, I assert that this division throws an arithmetic exception, and the test won't pass unless that happens. But even better, by the way, it returns the exception. So you could check the message that came back out of it if you wanted to. So you could do further processing. Whereas with assert does not throw, then you could say, look, you might have expected an exception, but nothing's going to happen. Right here, there it is, assert does not throw with this lambda that x divided by y is actually positive infinity. You're like, you've got to be kidding me, but that's actually correct behavior according to the spec. So good luck. At any rate, that's the only example I could think of where that actually occurs on a routine basis. You know, that's normal behavior. Okay, so then the weird ones, which this would be hard to write myself. I wouldn't even know how to go about this. Assert timeout and assert timeout preemptively. Both of those take an executable. The difference is assert timeout will let this thing run to whatever duration you said and then keep running until it finishes. And if it went past the duration you specified, it'll say, yeah, it failed by this much time. It'll wait and let you know how much it missed by. Whereas assert timeout preemptively will run the test on a separate thread. And if you exceed the duration you specify, it'll kill the thread. So it's up to you. I mean, I've worked with a lot of RESTful web services that are your traditional public RESTful web service, meaning it's either up or it's down. It either returns right away or it doesn't return at all, you know? So with those, I'll generally do an assert timeout preemptively, saying, look, I either got the result back I'm expecting or just stop, you know? Not gonna work. Whereas if I'm trying to satisfy some performance requirements, then I'm testing my own internal service or something like that with an SLA, then I want to know how much we missed by, for example. And that's what I have over here, down here at the bottom. Here is, I'm going to wait for 100 milliseconds. I'm just going to print hello. Again, that's an executable. I mean, if I can't print hello in 100 milliseconds, I got to give it up, you know. But this one, I'll say, you know what, I'm going to sleep for 200 milliseconds. Notice I don't need a try-catch block because executables throw exception and JUnit will catch it. I don't need that. Right? So at any rate, I'm going to wait 100 but sleep for 200. Here I'm going to wait for 100 and sleep for 200, but this one I'll do the exceeded with the assert timeout, and you'll see it'll say, oh, that's right, I disable it until the demo, right? Let's try that again. And I disabled the wrong one. There we go. There we go. And what it tells me is execution exceeded timeout of 100 by about 100. See, it went to the end and then told me by how much. Whereas if I do timeout exceeded with preemption, you know, preemptively, then it just said, yeah, you hit 100 milliseconds and it killed it right there. That's something I'm not sure how I would write. You know, I'd have to set up my own threading and everything to make that work. Here it's built right into the framework. Kind of a neat mechanism. I mean, it only comes up when you need it, but it's built right in. So it's great that it's there. Okay. Now here's, oh yeah, this is a really interesting feature. I mentioned that the third argument in all of these assert methods is an optional string message. But all of those are overloaded. It's not just a string message, it's also a string supplier. So you don't have to just put in the string, you could also just put in parentheses, arrow, and then the string, or some method to produce the string. And what this is for is lazy loading of the error message. And I believe I have an example of this. Yep. So here I have a method called create error message. Now right now it's just returning a hard-coded string and I'm printing that I was there. Java, by the way, has its own lazy logging mechanism too. So I included that as well. Now here's eager evaluation. I'm going to log at the fine level. I mean, among many reasons, this is one of the reasons nobody uses Java util logging. It's fine. I mean, one would debug, right? But in Java util logging, they have fine, finer, and finest or whatever. But okay, fine. Sorry, no pun intended. No, I'm going with it. That poem, wait a minute, I have something for this. Just a minute. There we go, okay. Got that ready to go, right on the desktop. Okay, so this is calling the method deliberately or directly. Okay, nothing lazy about that. Go call it. This one, on the other hand, puts the call to the right of a percent or parentheses arrow. That's a string supplier. If I run this, then what you'll see, I'm asserting true. I don't need an error message. And yet, I created anyway. I made it even though I didn't need it. Because here's a method call. It just normal Java evaluates the method. But down here, I'm creating an object. I've got a lambda here, see? So if I run this one, now neither of those things happen because the test passed. So you don't need to evaluate the error message. Now you can drill into this and see that this turns around and calls assert true dot assert true and turn it here, and here's where the magic happens. If the Boolean condition is false, then we create the error message. Otherwise, just return. I was sitting in a talk once where Trisha G., Java champion, and by the way, go see anything she talks about, was talking about working on the Mongo database driver years ago, where they built this mechanism in long before JUnit did it. They did it manually. And now, of course, it's built right into the framework. So that idea turned out to be so popular that it was adopted by the framework people in general. And it's really easy. Now, I gotta say, here, it's not buying me anything. I mean, this is returning a constant. But what if your error message was saying, okay, that's wrong, but here are the valid values, and it's assembling some complex information or looking something up in a database or a file or going over the network? You only want that to happen if the test is failing. Why create the error message otherwise? So they're using suppliers for lazy loading, which is one of the dominant uses for suppliers in the industry anyway. As you see, the Java library does the same thing with the logger class, right, like that. Okay, now, executable is not the only functional interface they created. They made that executable, which is essentially a throwing runnable, if you will. It's a runnable that throws throwable. Well, if you're going to make a runnable that throws throwable, why not make a throwing consumer and a throwing supplier as well? That one that I ran on the assert does not throw, I used what was actually a throwing supplier, parentheses, arrow, and then did the division. It would have returned a value. That's what suppliers do. They take no arguments and they return a value, but it might throw an exception. So the version of the assertion method I was using there was a method that took as an argument a throwing supplier, believe it or not, all because they're willing to let your test throw an exception. Now, you don't need this very often. I made a little video about it on my Tales from the Jar Side YouTube channel. Whoa, marketing. I feel like Neil Ford now. At any rate, this is talking about all these functional interfaces. The one you'll deal with all the time is executable. The others may or may not come up. The supplier as the overloaded error or the error message argument, that's occasionally coming up too. The others you may or may not see very often. Okay, here's another feature that is built right in to JUnit 5, but a lot of the community doesn't really know. These are assumptions rather than assertions. An assumption is what we like to call in the community a precondition check. Java doesn't really have precondition checks. I mean, a precondition, I usually start from the post condition. If I'm running a method, I say, what's going to be true after I'm done? That's the post condition. But that's only going to happen if the preconditions are satisfied, right? For example, okay, we will find the result of this, we'll get back a book from our lookup table or whatever, but only if our service is available and the reference is not null. Java doesn't have a built-in precondition checking mechanism, so we do the wrong thing. We use assertions as precondition checks. We use exceptions as precondition checks. I mean, what's a null pointer exception other than a precondition failure? I mean, you're not testing a method if the reference was null, right? You couldn't call the method. The reference was null. That should never happen. That's a precondition failure. But we use them everywhere because we don't have precondition checks. Now, there are libraries that do it, but none of them ever really caught on. JUnit has assumptions now. You wrap your precondition in an assumption, assume true or assume false, and then the test will be aborted if the assumption fails. See, that's the idea. And that way you know, oh, this didn't work, but it isn't the fault of the code I wrote, it's something went wrong with the precondition. So to give you a quick example of that, here is checking for an exception. There's an assert throws that's going to throw an empty stack exception. So I have a stack here, the old data structure that's been in Java from the beginning. You are not supposed to call pop on an empty stack because that throws a empty stack exception. Now that again, that's not a failure of the pop code, that's a precondition failure. They tell you in the docs, don't throw or don't call pop on an empty stack. Otherwise, there we have it. So I have this disabled at the moment, but if I run it now, you will see this does in fact throw an empty stack exception. Whereas here, I'm going to get the size and I'm going to put in my precondition check with an assumption. Assume true, that size is greater than 0. And I've got an error message. So now this is the attempt to call pop. This is only going to happen if the assumption passed. Then I can assert that the size went down by 1 and the element I got back is the element I'm expecting. But what actually happens, of course, is the assumption fails, and therefore, I don't know how well you can see it, but there's a circle with a line through it there going, no, I mean, that was disabled. We don't see the test at all because the assumption failed. Yeah, there's nothing in the output, unfortunately, in Gradle that way. And then here, of course, I have one where we push an element and then do the same thing and it works just fine. You may or may not decide you want to use this. I mean, it's completely up to you. I find it, where I use it, as I mentioned, I mean, most of us these days work with a lot of RESTful web services, you know, other services in your own organization or outside. As I say, sometimes they're up, sometimes they're not. If I wrote a bunch of code that's going to interact with a RESTful web service and then do some processing, why even call the service if the service is down? So I'll put in an assumption that does, for example, send a head request to the RESTful web service, just to see if I get a response. And if I get a response, I'll assume the site is up, and then I'll go and do my tests. But I could have a bunch of tests all on that RESTful web service. I'll put my assumption in the before each method, or maybe in the before all, depending on how granular you need it, just to see if the service is available before I waste my time doing all those tests. Okay? Again, this is up to you as to whether you find this valuable or not, but it's now built in. It's now built into JUnit. Okay, one of the things that JUnit does extremely well and makes extremely easy, boy, I like those terms together, is conditional tests. They can make your tests run based on what operating system you're on, or what Java version you're using, or even system variables, system properties, or here, I'll show you, system properties or environment variables, or even just some general Boolean condition. So let me start with this enabled on OS versus disabled on OS. And OS is an enum, operating system is an enum, and they occasionally add new ones to the list. I mean, it's always funny to see what old operating system they decide to throw in there. I mean, they got good old AIX on there. I had an AIX machine back in the 90s or whatever, you know. Solaris, too, is in that list. And, of course, there's always the ever-popular other, you know. So you could do pretty much anything. When you put in the enabled on OS enum, you can either pick one or put in several in curly braces separated by commas. Say which ones you want. That this test runs on Windows, this test runs on Linux, or whatever you'd like, however you want to put that there. There's also the ones for the Java versions. Like this is enabled on JRE and disabled on JRE, and then another one called enabled for JRE range, where you could put in a min and a max. Now the min generally defaults to Java 8 because JUnit 5 requires Java 8. And the max is supposed to default to whatever's current, but since you don't know what's going to be current in the future, it's best to put in an actual value there. Frankly, I put in a min as well, but just to be explicit, it's documentation that way. So over here, I have my conditional tests. And you can see, let me go to the top here, this test only runs on a Mac. That's the OS enum. This one runs on a Linux, Solaris, and Windows, for example, and not on any of the others. This runs on Java 8. This one runs on 8, 11, and 17. This runs on every JRE from 8 through 17. And then this one has just a min, or I could do just a max. That one's for playing around, in case you want to try it out and see what you get. So now, by the way, if I go into that OS property now, you could see there's our values here. AIX, now we have FreeBSD, Linux, Mac, OpenBSD, Solaris, Windows, other. Yeah, okay, so we got a pretty good range. And then what about the JRE enum? It looks like we have 8 through, we got 23 yet? No, we still got 22, and then other. Now this cracks me up because what else could it be? I mean, I guess it'd be 23, I guess, if you're running a beta. But by the time 23 comes out, JUnit will have upgraded and there'll be a 23 in there. Okay, what else can you do? Well, here is enabled if system property. So this will search for the system properties CI server and see if it matches that string. See, it says true, but it's not checking a Boolean. It's checking a literal string, character by character, which means you could actually put in a regular expression like this. I took that from the user manual again. os.arc, the system environment variable, is any number of characters and then a 64 and then any number of characters. So if it's got a 64 in it, you're using a 64-bit architecture, for example. And again, see how easy that is? Just enable or disable for that. I put in a method just to show my system properties if I want to see it. But down here, this is doing the same thing, but for environment variables. System properties you could set on the command line with a $D. Environment variables tend to be more in the environment, part of the operating system. Also, down here, I have this method called custom condition that returns a Boolean. So now I can go enable if and specify the name of a method that takes no arguments and returns a Boolean. And that way you can set up any arbitrary condition you want. Whatever you like to put in there, you can set up, and this one will be enabled because it's enabled if, and this is a disabled if. So you could turn them on or off. You know, like if I want to do enable, run only on 64-bit architectures in the US, whatever, there's your regexes, has at least 4 processors or whatever. You know, you could make up whatever thing you'd like to do, like runtime.get runtime.available processors greater than or equal to 4. See, that they don't need a constant for that. You could write your own Boolean to do it. Okay? Really easy to do. I really like that. Okay. So that's that whole list there. And there's the enabled, disabled ifs. And we did the test instance lifecycle. Already talked about that. Ordering. This has one of my favorite phrases in documentation I've ever seen. If you look up the section on test ordering in JUnit 5, they say the order of the test methods in a given test class is deterministic but intentionally non-obvious. Meaning it's the same every time. It's not random, but we're not going to tell you what it is because we don't want you to rely on it. We want to make it so that it's some benefit to us, but if we told you what it was, you might expect a particular order, and we don't want you to expect a particular order. They should all be independent. There are times, however, when you want an order, when you want to put in a particular order. And what they do is they provide, and this is the word they use, method orderers. So it's an orderer. And the one that I see the most is the order annotation. And to show you what this looks like, here's an example of some ordered tests. You see this has got a test method order where I'm using the order annotation. And you see that I've got an order 1, order 3, order 2 here. If you don't specify this order, the annotation, other ones are like whatever order the display names are in, whatever order the method names are alphabetically, well, lexicographically. You know, if they're all lowercase, then that's the way it'd be alphabetical. They've got a couple others, but this one allows me to pick an order, and those numbers don't have to be consecutive. It's just doing a greater than, less than sign on it. So they did put in, oh yeah, the random is also another possibility, although again, anytime they say random, they mean pseudo-random, but you get the idea. So you get to pick an order or intentionally make it random if that's beneficial. I have had too many times where my tests all passed because I got lucky, because the delete was at the end and it emptied the database, and because it was last, it didn't affect all the other tests. So maybe random's a good thing sometimes, you know. But at any rate, the default order is deterministic, but intentionally non-obvious. I need somewhere I can use that phrase. That's great. Okay. Now, my favorite feature of all in JUnit 5, the one I use the most, is parameterized tests. They have what they call repeated tests. I'm not showing that. Repeated tests is to run the same test a certain given number of times. But then the data is the same every time too. So unless there's something inside the test that's random, when do you need that? You know, I just haven't found a lot of good use cases. This one, on the other hand, runs the same test over and over with different data. And that's really useful. You know, like the Spock people have the data-driven tests, or they have things like that. Here, this is a way of saying, okay, here's where I'm going to get my parameters. Just go through each row, or go through each set, or go through each value. And what you need with a parameterized test is what they call a source. Where are we getting the data to run the test? And a value source is basically a collection of either primitives, any of the 8 primitive types, or strings, or the one I don't really have a use case for, classes. You could actually go through a series of classes if you want. But at any rate, there's a value source. That's all you can do with those. An enum source will pick, you give it the enum, and it'll run through all the legal values of the enum in the order they show up in the enum class. Not that the order is supposed to matter, but nevertheless. But the nice thing about that one is you could put in a regular expression and just say, yeah, only the enum values that match this particular regex. I'll show you an example in a moment. But probably the one I use the most is a method source, because you say, here's the name of a method that takes no arguments and returns something that Java knows how to iterate over. An array, a stream, an iterable, an iterator, anything like that, and it will iterate over each one for you. So you call a method, in the method you prepare the test data, serve it up. I mean, it could be reading it out of a database, it could be building up a list or whatever. I'm going to mention the last ones and then I'll show you the big examples. We have a CVS source if you're searching over prescription medication. I'm sorry. Wait. Oh, come on, do it. Now, there we go. Okay, now, no, CSV source, obviously. Comma separated values really kills the gag if you got to sit there and hit the button every time. Oh well. Yeah, CSV, comma separated values. In the CSV sources, I'll show you, you could specify the delimiter. It doesn't have to be a comma. You also have a CSV file source where all the data is in a file somewhere. And on that one, I really like it. You can actually put in a header line that people can read to know what these columns are and tell it how many headers to skip, how many lines to skip when you're doing this. And then finally, the one I need to mention is the argument source. All the rest of them, like value source and enum source and everything, provide a single argument that you put in your test method. Hey, for every integer in this collection, 3, 1, 4, 1, 5, 9, do a test here, okay? But if you wanted to put in 2 arguments or 5 arguments or whatever, that's what an argument source is. An argument source is saying, yeah, here is a collection, some list of these groupings, like a list of triples, for example, if you had 3 arguments. So you could bundle them all together. So let's take a look at that. Okay, so let me start at the top here. So this is a parameterized test that a value is prime and less than 20, and here's my value source with the prime numbers less than 20. And notice how the values here go into the argument of the test method automatically, as well as showing up on the test report. And this is nice because this way when you run the test, you get an individual output for each test that you ran, and that's really useful. And they're all nicely nested as well. So that's good, and then I did the composite ones as well, just to show I'm not just returning true, you know, in that example there. That's a value source. Here is a method source. Now with a method source, the rules on the method are it has to be a factory method, meaning no arguments. It has to be static, so you don't need an instance in order to run it. It has to return, and I just collectively say something that Java knows how to iterate over. So a stream, an array, a collection, which is an iterable, or an iterator. So this one is saying, let's go from 2 to 100, and I'll just grab the prime numbers and try to ignore the fact I'm using the same method to generate the primes as to test them. Okay, so ignore that for the moment. The point, however, is that when I run this, I get all of those tests being executed. See? You just provide a method to give you the data. There's another feature which I'm not going to really get into called dynamic tests, where you have a test that generates tests. The problem is that every time I think I come up with a use case for that, I figure out a way I could do it with a parameterized source, like a method source. So I don't have any really good examples of that, and the ones that are in the docs are not terribly motivating. So I'm expecting that'll get better. It's still listed as, quote, experimental anyway, so I'm giving it time before it's fully officially released to see how that goes. But boy, isn't that nice, you know, to be able to run them all like that. Now here is, let me go down to, where's my enum source? Here. So this is going through the month enum, for example. So I have an enum source where I specify a month, and again, I was fishing for things to check. I just make sure that it's not null and that it's in this collection I had of months or something like that. But each one, if you look at when you run it, will run through all the values in the enum, all the way like that. And then here I took from the user manual, this is looking at all the chrono units in the java.time package that have a name that matches, well, this is basically saying any number of letters and then ends in the word days. So in other words, this is matched by half days, and that's it. It still kind of blows my mind that we have half days as a unit inside. I'm still looking for a use case for that. If you find anything, send me an email. I wonder what it was. Okay, here is a CSV source, and the thing I use the CSV file source more than this, and the reason is the CSV source, you hard code in all the data right in the test itself. So I put in this list of title, comma, URL, you know, for all of these different books here, and this does, it fills in the values, splitting it at the comma. The white space is ignored by default, so that works. And the first value goes in the first parameter, and the second goes in the second. And this one doesn't need it, but it can do many type conversions for you. Like it could parse out local dates. It can switch to different primitive types. I mean, it can't get really complicated, but it can do a lot. So this one basically will run through them all and say, yeah, the title's not null, and I borrowed a URL validator from the Apache Commons Validator project, just to verify that that URL is valid, which is just a regular expression, you know, for URLs. This one, on the other hand, would retrieve a book. Let's come back to that. Where's the one I wanted to show? Here, there we go. Here is bookdata.csv. Now, in IntelliJ, I have a plugin here that's rendering this as a table. But if I just, this is the raw text with some syntax highlighting. You see how I have a header row with the names of each column in there, and then the rest is just separated by commas? Well, back in the test, you'll see that this is going to say CSV file source, resources, plural. I could put in multiple CSV files. This is right under source main resources in my project. Num lines to skip is 1, and I didn't even need to say the delimiter, but I did, because why not? you know? And it converted, these are all strings, and this is a local date. And it parsed the local date out of it and ran through the whole thing and did them all just fine, okay? This one, I used what's called a book aggregator. Well, actually, aggregate with, this is my book aggregator. It implements some arguments aggregator where I wrote the little method myself to convert this arguments object into a book. So there's my Pojo. And this one I even went to the point of making my own annotation, which is basically aggregate with the book aggregator. So now the whole thing's written in terms of a book and it all is exactly the same, okay? You don't need to go that far on it. Just the CSV source is very useful. Okay, last thing I'll mention, because we're running out of time anyway, is JUnit recently added this out of experimental range. If you want your tests to run in parallel. Now, I've been running tests in parallel with Gradle for years because all you have to do is go into your build file and set the num forks, is it a blank, something like that, whatever the property is, and set it to something other than 1, okay? And that'll work. The problem is with Gradle, that will give you the individual test classes running in parallel, but not the tests inside an individual class. Okay, so if my single test class had 10 tests in it, they're going to run in whatever that deterministic but non-obvious order is, okay? This, however, if I was to enable this and set the mode to concurrent in the JUnit platform.properties file, then all the tests run in parallel, even the ones in a single file and everything. And that works really well. I find it useful. I have an example where I do it, where I'm playing around with a REST client in Spring, just to show, for example, what that's doing is that's accessing a GitHub repository. Well, no, it's a site that provides test data in general, and there's like 100 different posts in it, and it's called JSON Placeholder, in case you've never heard of it. It's a good site for test data, and I'm going to call get with the numbers from 0 to 100, so I made them run in parallel, and you can see they're all running at the same time, and you get a jumble on the output. You know, it's really easy to do. I just had to turn that on inside the project. Okay, there's extensions for a ton of different platforms. I use the Mockito extension on a regular basis. The Spring extension is built right into Spring Boot. You don't have to say anything. You don't have to put this in there. If you use a Spring Boot test on any version of Spring with a 3 in the name, you know, and certainly, and a lot of the 2s as well, then this is already in there. It's already a part of the @Spring Boot test annotation. It's bundled right inside. So anything we've just seen today, you can do with Spring Boot. Conclusions, I mean, JUnit 5, I really like all these things they do, and a lot of people don't use a lot of the neat features that are very simple to use, and they're right in there. I spent enough time on Mockito, I wrote a book about it, so I like that one, but we don't have time to talk about it. Also, another thing I learned from the Spring Boot people was about the AssertJ library. The AssertJ testing library it's syntactic sugar, but it's wonderful. Basically a great replacement for the Hamcrest matchers. Goes way beyond that. And then I'll just mention again the Tales from the Jar side, the newsletter and the YouTube channel has videos on a lot of this stuff and everything there. And I'll hang out for a few minutes if you have any questions or comments, but otherwise I'll just say thank you for coming. Yeah.